Okay, so I want to illustrate just a furthering fact about the area of a triangle. So basically, what I want to state is that even if the triangle is in this configuration and you draw a height from this point over here, right, this point, if you draw a height from that point, it goes down, so it forms a 90-degree angle with the extended line here. So this is the extended line. And it will still be the case that the area of this triangle will be 1/2 the base, where this length is the base. Just this piece is the base. Not this whole thing. Just this piece of the triangle is 1/2 base times this length here. This altitude or this height. And I just want to convince you of this. So the way it is that we're going to convince ourselves is that we're going to take this triangle and we're going to duplicate it and we're going to rotate it around. So this angle right here, this angle, this blue angle right here, is going to come up to over here. So this blue angle came to over here. And then this angle over here, let's say, I don't know, this orange-red angle came to over here. Red angle came to over here. Now, again, these two triangles are exactly the same. And if you notice, when you flip it around, this side is still being glued back onto itself, just in a reverse way. Now, all we need to do is just convince ourselves that this here is a parallelogram, and we should see that this height, right, this will be h, right, this is still h over here. From here to here is the same length as from here to here, as long as it's a 90-degree angle. And once we convince ourselves that this is a parallelogram, we should convince ourselves that base times height is the area of a parallelogram. This is 2 of those triangles, so 2 times area of triangle equals area of parallelogram. And yeah, so this is 2 of them, so obviously 2 times the area of the triangle is going to be the area of this parallelogram. You only need to convince yourself that it's a parallelogram. How do we do that? We do that by just saying, well, let's see, is this line parallel to this line? Yes. Why is that true? This line and this line, let's look, and then this angle is the same as this angle. So this angle is the same as this one. We know by alternate interior angles converse theorem that then this line will be parallel to this line. These 2 lines will be parallel. Okay, so if, right, remember the statement, alternate interior angles congruent, then lines parallel. Then the lines are parallel. And similarly, if you look at these 2 lines like this, right, and then this again, so it looks like this, and then you have this here, right, and we look at the red angles, which are here and here, right, again, these are alternate interior angles and they're congruent. So by this again, we have that this line is parallel to this line. And then that means that this is a parallelogram, and that the area of the parallelogram is just base times height. And then that's 2 times the area of the triangle. And then we get that 1/2 base times height is the area of the triangle still. And that's all it is that I really just want to convince yourself that even when it's in a weird configuration, it doesn't matter, right? Like this one, right? Like take this triangle. If I draw, right, from any of these points, like the altitude here, right, the length of this height times the base that it's perpendicular to, this base, divided by 2, so base times height divided by 2 will be this area right here, even when it looks rather strange, is the whole thing. And then that's it. Oh.